Hello, I'm James Ingram for autocontrols.org. In the previous video 820, we looked at the DCC, DCS switches that are found on Proto 3 locos, or should say found on the Proto 3 Premier locos and need to be added and can be added to the Proto 3 Rail King locos. In this video, we're using an NCE brand DCC power cab unit to operate an MTH Proto 3 three-rail O-gauge locomotive. In a future video, we'll show an NCE automatic train controller automatically operating this engine point to point. Now, I've got to give a warning. NCE says not to use the power cab on O-gauge like I'm doing here in this video because the amps are too low and the voltage is too low. However, I already had this video shot and it does work for my purposes here. My power cab unit is an older one and it has a 1.3 amp capacity. The newer power cabs have a 1.8 amp capacity. The power cab itself can handle a max of 3 amps for a short period of time. And we think it can handle around 2 amps continuously. But these engines can pull up to 3 amps if they're heavily overloaded, which is why NCE doesn't want you using the power cab. And also, keep in mind there's an O-gauge railroading DCC forum. You can browse discussions on using DCC for 3-rail O-gauge, and that forum, you don't need to register or anything like that to browse the discussions. It's public, so you just find the web page, which I'll give the address here, and you can go in and browse the discussions. And also, there's a Yahoo group for NCE DCC users if you're interested in that. Thanks for watching. Here's our engine sitting over here on the left in our NCE power cab. I'm going to power this unit up by pushing this button, and our power supply is here, and you can maybe see that screen lit up as it's booting up, and there's also a red light over here on what they call the power control panel that tells us this thing should be up and ready to go. Now we can turn on the loco sounds by toggling the function 3 button, which is what I'm going to do next. So here's function 3, and it's on, it's off right now. Now it's on, and I got that successfully started up. You can see the headlight came on, probably because I had it on before. There's a button here for headlight, which is right here where my thumb is, and if I push that off, the headlight turns on. I push it on, it comes back on. You can see there's an L here. That L turns off and on, for that indicates headlight. It's really function 0, but it tells you the headlight is on. And we also have a button for the horn and the whistle. That's right here, where I can hold that down. And the center button there is the bell, and that toggles. If I push that, it'll stay on until I push it again. And let's put this in, I'm going to put it in reverse. I've got to go back and get those cars. I'm going to push the direction button, and we'll hit this increase button. Now we went to speed step 1 in reverse. I may have to go manually pick up those cars. Yeah, I'm going to have to manually do that. Now we'll go to speed step 1 here if we can. Now we're running forward in speed step 1. And our amp meter here is reading right around the ½ amp. This power cab unit is really intended for smaller trains, not O-gauge. But I found with a small O-gauge engine like this, if I keep the loads light, I seem to be able to successfully operate this engine. We got actually up to 28 speed steps on this. Most people run these things set to 28 speed steps, and like I said, we're running speed step 1. I don't know if it shows on the camera, but it says Loco 101. That's the number of that diesel. Forward, that's the direction. 1 is the speed step, and its upper right corner tells us the amps we're pulling, and the lower right corner tells us which of the lower functions are on. Now let's go up another speed step. There's speed step 2. And that's basically what it looks like running slow. We'll go up to speed step 4. And I don't want to go up too fast because the engine really flies. It would probably come off the track. We're operating at 13 volts. The power cab is fixed at 13 volts, as determined by this power supply, and it's a maximum of 1.3 amps with this power supply. It's limited by this power supply. NCE says this thing can actually handle somewhere around 2 amps continuously and a temporary maximum of 3 amps. They say if you run 3 amps for very long, it'll melt the case and distort the case. But the system as I have it here, which is out of the box, we're limited to 1.3 amps. And if it overloads, it just shuts down and reboots, so it doesn't damage anything. Let's go up to speed step, hit this button here. That'll take us up to speed step 8. This increase fast buttons, these increase by 4 speed steps on my unit. Now we're at speed step 8, everything's fine. There's speed step 12. Now we'll hit the direction button. I just threw it into reverse, and you can see what happens. It slowly ramps down to 0, sits there for a second, and then it starts back up. I reduced it to speed step 8, and all DCC decoders I've seen do this if they have their momentum adjusted, at least a little bit of momentum. They make a gradual stop. Now we'll go back to forward. And you can see the engine went back to forward. And I haven't adjusted the momentum on this. It's running with however it came from the factory. And we have our F5. Let's back up just a second, just a little here if we can. I believe it's F5 is our lights for our number board and our cab. You can maybe see the 101 number up on the number board lit, and we also have cab lights. And if we hit the 5 key here, that turns off. You may be able to see the cab lights went off and the number board went off. If I push it again, they come back on. And our coupler is, our rear coupler is F8. So we move slowly ahead in the forward direction, and I push F8. There we go. The coupler uncoupled as it's supposed to do, and I believe it's F7 operates the front coupler. This is the function chart that comes with the manual that came with this locomotive, and you can see they give you a list of functions 0 through 28 and what they do. And I believe you can do most of the same things you do with DCS by using these functions. I'm not sure because I don't know much about DCS yet, but here's what you can do with the DCC functions, and the common ones like headlight, bell, horn, startup, shutdown, the freight talk or whatever that is, PFA, lights and whatnot, the couplers, they're mainly F0 through about F8 or so, and then some other stuff on the other higher functions that I haven't really used these much. Here's the index from my DCC instruction manual, and you can see they start DCS operation on page 14, and it goes all the way through page 31. So you've got 16 pages of well-written, well-thought-out instructions on how to control this locomotive using DCC. Here we are now with a longer train. We got 7 cars on the train. Let's take a look at that situation. We'll go to speed step 4 here. You can maybe see at speed step 4, this thing is pulling a half an amp or a little more than a half an amp, but we're still within our operating range. However, if we start speeding up, we'll start pulling more amps. We'll go up to speed step 8. Now we're starting to push closer to 1 amp. Like go up to speed step 12. We actually pulled too many amps, and you can see what happened. The unit shut down, so it's rebooting now. We'll wait till it reboots, and we'll try that again. Now we're back up, and the power cab has rebooted itself, and as I said before, this doesn't hurt the power cab. It's actually I believe it's the power supply that's cutting out, because like I say, this thing's good for a peak of 3 amps before it shuts itself down according to NCE. Now we'll do our startup, and we'll go to speed step 1, and for some reason this darned coupler always uncouples itself when I start it up. That's one thing I'm not a big fan of, but there's speed step 4. Go back up to speed step 8. There's speed step 10. Hit the direction button. See, it still comes to a smooth stop when you push the direction button, sits there for a minute, and starts up again. Now it's running speed step 10 in reverse. Again, pulling sometimes over an amp. Now we'll hit the direction again. Now I switched it back to forward, and you can see it slowly slows down, stops, and speeds back up again. So this is kind of the maximum, and I just hit the emergency stop button. For lazy operators like myself, you can use the emergency stop button if you have like a derailment or something's on the track you forgot to take off the track. And for one train, that's no problem, because emergency stop will just stop everything, and then you can start up again like normal. This would be possibly, using the power cab would be suitable for something like a small train around a Christmas tree, or some kind of a small Department 56 display, or in the case of this video, I'm going to use to do an automatic point-to-point demonstration using the NCE mini panel next. One thing interesting to note, apparently MTH has put a fairly large capacitor in this engine for sound, because it's sitting on the track, as you can see now with the engine running. But even if I take it off the track, so it's now not getting any power, it'll still sit there and idle for a few seconds. There, it finally went off. You may well know this better than I do, but just to take a quick look at these systems, here's the MTH DCS system with a power supply. This system belongs to my friend Bob Schild, who was kind enough to loan it to me for the video, but he's using a Lionel brick to power this. This is your TIU track interface unit and your MTH cab. So this is what most people running Proto 3 engines are probably using to control them digitally. Now if we move over here, we've got an NCE system set up, and it's similar. We've got a power supply, a TIU, and a cab. NCE doesn't call it a TIU, they call it a command station, but basically does the same thing as a TIU. And here's actually the front of the thing here where the connections are made. This one's a 5 amp unit, and actually I believe NCE tells you if you're running an O-scale layout, they recommend the use of their 10 amp system, not even this 5 amp system. But for one train, you can see we've been able to get away with the power cab, and that's the next thing we're going to look at over here. Here's another unit. I've labeled it NCE TIU, and this is the power cab. If I turn it over, you can see it's the same unit we've been using for this video, and it looks like a regular. It looks a lot like a regular cab, but it may be just a tad thicker. What they've done, they've actually built a command station into the back of the cab. So it gives you a very compact unit, and it's got a capability of 1.3 amps, which seems to be adequate for running a small engine like we've been doing in this video with just a few cars. And here's your power control panel, and this is what hooks up to the track here. And these things are well respected by model railroaders. They're built right here in Rochester, New York, in the United States, and they're considered more or less bulletproof as far as their reliability. Let's take a quick look at this cable that is used on the power cab. Here's your power supply, and that power comes in this wire into this terminal here to the power control panel, and then it goes via this flat cable up into the power cab itself, and then the power goes back down the same cable to the power control panel and out to the track. And these wires they use for connecting, they're actually nothing but essentially telephone cables. It's a fairly light gauge wire. So as I mentioned, there's 2 wires to bring the power up, 2 wires that take the power back as DCC track power, and then the other 2 wires are for the control bus. But you can see this isn't an ideal arrangement for carrying a lot of power, or it'll actually supposedly heat these wires up. And here's a bit of just historical trivia. All this new equipment is labeled NCE, as you can see there on the power cab and everything else. But this is an old regular Pro cab, and you can see it doesn't say NCE. It says from, if you can read it, North Coast Engineering. So that was the original name, I believe, of this company, North Coast Engineering, and then they later shortened that to be NCE. Here's one of the NCE web pages from their Zendesk articles, adding more capacity to the power cab. And they mentioned that the power cab actually has a 3 amp maximum current rating before it will shut down. But the power supply that comes with it in the new ones is apparently 1.8 amp. And as I mentioned, what I've been using for this demonstration in this video is an older unit that's limited to 1.3 amp. And then down here they mentioned you cannot run 3 amps continuously. It will overheat with the power cab shell deforming to the high heat buildup. And they also mentioned the long flat cable will lose a lot of voltage and get warm since it's using telephone jacks, and they're not really designed to support 3 amps. And here's the most important, the preferred method for adding more capacity to the power cab is the SB5 Smart Booster. And when you use one of those, you have a 5 amp capacity, and the power cab gets turned into a regular cab and communicates with the smart booster. So really, they don't really want you going much over this 1.8 amp capacity. They would rather have you, acquire a smart booster, which has the more capacity. Just as a reference, I've hooked up one of the 5 amp Power Pro systems here, and through this rat's nest of jumper cables, I've connected a RR amp meter, which is a DCC amp meter designed to measure DCC voltage. You can see 17 volts and 0.12 amps of current. I've got my, over here I've got the Power Pro voltage adjusted as high as it can get it. It's supposedly adjustable from around 11 to 16 volts, and I've got it cranked all the way up. And the idea is to run this locomotive up against this pile of catalogs. I had to put a brick on top of it to stop that engine, and we'll try doing that right now. I just got to crank that up to speed step 28 as fast as I can go. You see it pulling over 3 amps stalled, so that gives us an idea of how much amps this engine can pull when it's heavily loaded. So you can see with using a 1.3 amp power cab, as we've been doing for most of this video, we have to keep this engine very lightly loaded, or our amperage will easily exceed what the power cab is capable of.